Hello and welcome everyone. In this day 25 learning, we are going to be looking at tree traversal. We had an introduction on trees, specifically binary trees, right? Where there is going to be two nodes, uh, that is left and right node, right? Now we are going to be looking at how we can traverse a binary tree. Let's say, for example, let's say we have binary trees such as 1 and 2, 3, 4, 5, and let's say 6. So let's say this is a binary tree here, and the, there can be different ways of traversing, but few major traversal options that are very prominent or maybe an interview type questions are: one is a post order traversal, where we start from left, right, and node. In case of pre order, there will be node and left and right, and third one will be in order, right? In order, where there will be left node and right. So these are all the possible combinations that we can traverse a tree with. In other words, let's say if we think about this as root node and this as left and right nodes or children to this root node, the possible there can be six possibilities. For example, let's say we can start out left, right, or let's say we call this root node. Let's call this node. This is left node, right node. Possibilities of is, let's say, left node and right. This is one possibility, and we can even have node right and left. That's one possibility, and another one will be L R N, right? So another few possibilities that we can interchange all these, and we can have a few other six possibilities we can come up with. It's like combination of three items in multiple ways, right? 3 CR. Like like we have three items L and R, and can we can permute them like 3 factorial. These are the different possibilities that we get here. Okay, so that's about uh, the important traversal techniques. Now there is now let's look at the code snippets for each of them. Like for example, post order, pre order, and in order. And we know that reversing all of them will also be a possibility, right? But we will look at these three major traversal techniques, and at the end I will even talk about level order traversal. As the name suggests, we go by each level. Let's say this is level 1, level 2, level 3, right? Level 1, 2, 3. So we create we traverse the binary tree based on levels. Okay, I will start a new page just to also visualize the other three traversal techniques here: post order, pre order, and in order, similar to level order where we were going height by height. So let me switch to a new page. Here I have I will keep a copy of this specific. So let's say we are talking about uh, pre-order, which means, let's say firstly I will draw out pre-order, which would look like, let's say I draw out a horizontal line. The pre-order will look like something like this. So this means first goes the root, left and right, right? So it would be 1, 2, 4, 5, 3, and this is an quick way of visualizing how the pre-order traversal would look like. So instead of having to say R, I will, and similarly, I will also add in the traversal visualization for, let's say, post order. This would be no, this would be this way, and this one. So it would be 4, 5, 2, 6, 3, and 1. Just to put it, it would be left, right, and the node. This would be the post order traversal visualization. And lastly, we also need to worry about the in order, which is the easiest one to visualize. Just drawing out horizontal lines here would suffice, which is left, node, and right. So here, if you see 4, 2, 5, 1, 6, and 3. So these are the different visualizations for in order, pre order, and post order traversals that we have, right? So let me switch back to the level order page where uh, we were going with different levels. Like the first level had 1, the second level had 2 and 3, and 3 and 4. This is also called breadth first search. Okay, let me switch to the JSPin editor. Let's start going through the code examples that we have for post order, pre order, and in order traversals, right? Okay, so here you see I have already pasted a class for a tree node which has these different parameters such as a value, a left pointer, right pointer, and we have these different functions that are used for traversing through the node. Pre-order, we know that we are going to be having node at the start and then left and right values which are going to be iterated. So if you see, we have created this recursive function which firstly pushes this specific node value to the output that we are looking to print, and the left and right elements are going to be iterated till we reach the leftmost value and the rightmost value in the from the node. Uh, let's say let's say for example, uh, as you can see here, for I will run this code snippet. So let's say we have given this specific input 1, 2, 3, 4, 5, 6. So the pre-order traversal will be the node here and the left pointer and the left one, and then we traverse back to the node and the right value, right? So 1 2 4 5, and since once this is done, then we again go to this specific node, we check if there is any left value. So this is the only value, so we iterate through this one. There is iterative implementation also that I've done through this one, so you can check this out. But uh, understand the time and space complexity between iterative and recursive solutions, where recursive solutions will have higher space complexity because they involve recursion stack. Also, in case of uh, an iterative traversal of pre-ordered solution will have a little stack memory, so it will be O of n. In case of here, if you see, it will be O of n plus h. That's the worst case time complexity, right? So yeah, iterative solution, we have a stack implementation here where we uh, initially start out with a root node, and then we pop it out, and then we push it to them, and then we traverse through left then we traverse through the pre-order. Okay, then we traverse through, uh, we add these two to the right and left values. We add the right and left values to the specific stack, and we continue traversing until we end up with no items in the stack. So that's the implementation here. Just to understand this better, this would be like a LIFO queue where we are pushing uh, the right value before the left value. So that's the whole point here when we are traversing with pre-order iterative implementation, right? So so first we push out the one, and then we are pushing uh, 3 and then 2 as per the nodes that we have here, 3 and then 2. Then since 2 will be the last value, then we push to the stack with the right value, which is 5 and 4. And since 4 will be the last one which doesn't have any more child nodes, we push that to the output array, which is going to be returned out. This is the general idea. You can go through all these three different solutions or three different traversal techniques that we have. It would be easier for you to understand. And coming to level order traversal, uh, while the level order traversal will have a queue type of data structure, while we had seen the stack implementation for the other pre-order traversal. Here in this one, we would be pushing left and right values to the stack. If you see, right, uh, stack, which not the stack. This is a queue implementation where it will be first in, first out implementation. So let's say we start out from 1, then we push the left value, which is 2 and 3. Then once we unshift, we are going to get 2. Then again we push in these two values and move this one to the output value. And then we have 3 node which has a child of 6, which we push left and right. Since it wouldn't be having the right pointer, we only push 6, and the other values will be the left out leaf node, so it will be directly pushed out to the output value. So level order traversal will be with each levels, like for example 1 2 3 4 5 6. So that's the output that we are seeing here. So go through the other post order and in order traversals. It should be pretty much easier to understand. One, if you are seeing the recursive implementation, it would take some time to understand the iterative approach. Please do try understanding the iterative approaches better, right? So there is one last thing that I want to talk about: the n array or the n array binary tree implementation. Let's say there are there is a tree, let's say a root node of A which has multiple children nodes of BCD. So this is something that I have demonstrated here, where an node A which will have B, C, D, and B having G and H as its children nodes, and C and D are also a children node to A. So this is one other thing that I've shown here, and this is the way it can be. This such array, such binary, n array binary trees can be implemented, where children will be of an array, right? So I've even added some code snippets to show the level ordered traversal for them, right? Just understand this on a code level, or maybe just a general thought, and the solution implementation would be a lot more easier. Like we have pre-order traversal for this one, which goes root then children left to right. For example, let's say we push out the specific node value and we iterate recursively to all the other childrens, which goes left to right, because we already are storing the children nodes in an array format. So that would be the easiest one. Pre-order traversal is more easy. So in case of level order traversal, the same kind of queue implementation has been shown. So these are all the different traversal techniques and the n array binary tree concept that I wanted to show. Hope you found this video helpful. Please do like and subscribe to my channel. If you find any thoughts or any questions that you want to post me, please do post them in comment section, or you can even reach out to me via my contact uh, email ID or so. Thank you.